Welcome back to our sessions on simple chemistry for KCSE. As we said, our aim is to make chemistry very simple and to make students get it that it is very easy to pass chemistry. We do this topic by topic and simplify them and make them very easy to understand and therefore very easy to pass exams including KCSE. Today we are simplifying a topic called water and hydrogen, which is in Form 1, that term. So we start by looking at the sources of water, and there are two sources of water. One is the natural sources like lakes, rivers, rain, oceans, streams, and then there is the artificial source of water, which is mainly burning of organic substances, for example the hydrocarbons. These are the compounds that are comprised of carbon and hydrogen only. So as an example, just to illustrate how it is possible to get water from burning of hydrocarbons, we are burning a candle in air as per the setup that I've displayed here, where we are burning a candle in air, and then whatever is produced as a product of burning, we pass it to tube A and tube B. In tube A, there is anhydrous copper sulfate, which you will notice that after we burn the candle, after some time it will turn from white to blue. This is a confirmatory test for water, which confirms that one of the items produced from burning of the candle is water. Then in tube B, there is lime water. And what will happen after some time, a white precipitate will be formed inside there because that confirms that there is some carbon 4 oxide produced in the burning of the candle. As we saw in the air and combustion topic, when carbon 4 oxide reacts with lime water, a white precipitate is formed, which is calcium carbonate. So in tube A, it's confirmed that water is produced from burning of candle, and in tube B it is confirmed that carbon 4 oxide is produced from burning of the candle. So these are the observations that are made. You'll notice that there is some cold water here, ice cold water, which is meant now to cool the vapor that comes from burning, and of course so that it can be liquefied to water. So candle is a hydrocarbon, and therefore the hydrogen in it burns in air to form water, while the carbon in it burns in air to form carbon dioxide, as per the two equations you can see. Hydrogen plus oxygen is water, and carbon plus oxygen is carbon dioxide. The conclusion is that hydrocarbons burn in air to form water and carbon dioxide. The confirmatory tests for water, there is one, the physical test, which is boiling of the water, and you notice that it boils at 100 degrees centigrade. So anytime you want to confirm the liquid you have is water, just put it in a beaker and boil, and if it boils at 100 degrees centigrade, that is water. The chemical test says that it changes anhydrous copper 2 sulfate from white to blue, like it has happened in our experiment here. Then it also turns anhydrous copper 2 chloride paper from blue to pink. Now, properties of water. One is that it is colorless, it is odorless, it is tasteless, and it is neutral. 2, water dissolves many substances, and that's why it is called a universal solvent. 3, it contains 35% oxygen dissolved in it. Number 4 is that it exists in inconvertible state. That means it can state from liquid to solid to gas, back to solid, back to liquid, through the normal processes of changes of matter that you are taught in your initial classes in Form 1. These are freezing, condensation, melting, evaporation. Through all those processes, you can convert water from one state to another. It boils at 100 degrees centigrade, it melts at 0 degrees centigrade, and its density is 1 gram per centimeter cubic. We look at the reactions of water, starting with cold water and metals. You notice that whenever cold waters react with metals, the metal hydroxides are formed plus hydrogen gas. So the behavior and the rate of reaction is determined by the position of the different metals in the reactivity series. So metal plus water, you get a hydroxide plus hydrogen gas. The setups are as illustrated here, where we have a gas jar inverted and then a metal down there in water. Here we are using sodium for illustration. As you can see, it is wrapped in some wire gas because sodium is less dense than water, therefore it must be forced to go down in water. So you notice that hydrogen gas will be formed, and inside down here there will be formation of the hydroxides. Remember, hydroxides are alkaline and therefore they are basic. So in a summary, potassium and sodium, they are very explosive when put in water, and therefore they are violent. Of course, potassium is very violent, and it is even not advised to react it with cold water. So these metals, the two metals, they melt whenever they are put in water because the reactions are exothermic, producing some heat which melts the metals. There's said on sodium and even potassium, they are less dense than water, so they will float on top of water. So to bring them down, we normally wrap them in wire gas so that they are forced to go down for reaction to happen. As you can see, the sodium plus water is sodium hydroxide, which is colorless, plus hydrogen. The same case with potassium. When it reacts with water, potassium hydroxide is formed, which is colorless, and hydrogen gas is produced. In cases of lithium and calcium, they are dense than water, so them they sink down there in the trough, and there is a rapid bubbling of colorless gas, which is hydrogen. And for them, white suspensions are formed because their hydroxides are white in color. Now, that is a reaction with between cold water and metals. Let us now look at the reaction of steam with metals. Remember, water you can convert it to steam by boiling. So this steam or heating, this steam also there is a behavior it exhibits whenever it reacts with metals or metals are burnt in it. So in metals, in steam, when it reacts with metals, oxides are formed plus hydrogen gas. Remember, up there with cold water, hydroxides are formed plus hydrogen. Here, oxides are formed plus hydrogen. The reaction, as it was the case with cold water, is dependent on the position of the metals in the reactivity series. So metal plus steam, you get metal hydroxide and hydrogen gas. So points to note: potassium, sodium and calcium are not normally, it's not advisable to react them with steam. This is because the reactions are very explosive. So for potassium, sodium and calcium, avoid reacting them or burning them in steam. Lead, copper and silver, they don't react with steam. So now you are left with about 4 metals that are able to react when burnt in steam. For magnesium, a white powder is formed whenever it is burnt in steam, and of course a colorless gas is produced, which is hydrogen. The white powder formed here is magnesium oxide. For aluminium, the reaction just happens for a while and then it stops. This is because the aluminum oxide created here or formed in this reaction is insoluble. It just covers the coating of the aluminium. It covers the aluminium and stops any further reaction. In terms of zinc, the metal changes from gray to yellow, then white. This is because the zinc oxide created is yellow when hot and white when cold. For iron, the metal changes from gray to black because of formation of black iron oxide. The setup for these reactions we have two alternatives. One, you can use a setup like the one I'm displaying here, where we are heating wet cotton wool or wet sand, which now produces steam after heating that reacts with the metals. So in this setup, we are heating cotton, grass wool, or sand, wet sand. All these should be wet. So what you should notice that the wet cotton wool or grass or sand are heated first before the metal is heated. Remember here we have two heating points. So you should start by heating the wet cotton wool or sand for two reasons. One is that you want to drive air that is in the apparatus before you can start having the reaction between the steam and the metal. You drive out the air so that it doesn't interfere with the end product and the behavior of the reaction. The other reason is that you want steam to be produced, to be available in the tube before you start heating the metal, because here we are checking the reaction between steam and metal. So if you start by heating the metal, there will be no steam at that point. So what you should do is first heat the wet cotton, grass, or sand, so that there is some steam inside the tube as you start heating the metal. Now the delivery tube here should be removed before you stop burning at the end of the experiment, because if you stop burning first and then remove the before you remove the tube, there will be suck back of water. The tube here will suck back the water and bring it back to the apparatus here, which can make them to crack. So to avoid such cracking and such happenings, you first remove the delivery tube before you stop burning both the metal and the wet cotton wool or sand. So alternative B or alternative 2 of the setup is now like I'm displaying here, where I'm replacing the wet cotton wool, wet sand, with water, the conical flask, or with water. What happens here is that we are heating water direct, and then the steam is being produced from direct heating of the water instead of using the cotton wool or sand like it was in the alternative setup 1. So good, we are done with water. Let us now look at hydrogen as the next subtopic in this topic. We start by looking at the process of preparation of hydrogen. What is happening in the setup I'm displaying here, dilute hydrochloric acid is being brought down to the flask containing zinc granules or zinc pieces. This is done through the Disto funnel. So what happens when the zinc reacts with hydrochloric acid, the hydrogen gas is produced, which is delivered to the trough and collected in the gas jar through the over water method or downward displacement of water method. So in some cases, the process is hastened. The production is hastened through inclusion of copper 2 sulfate as a catalyst. So you will find that in some setups, copper 2 sulfate is also added down here in the flask just to hasten the process as a catalyst. Remember, we said a catalyst is a substance that is used to alter the speed of a reaction and remains unused or remains in its original state. It's not consumed, not used during the reaction. So when the acid comes into contact with the metal, there is rapid bubbling, and the hydrogen, which is colorless gas, is produced corrected through a water method, because 1, it is insoluble in water or just slightly soluble in water, and 2, it is less dense than water. The first jar collected should just be discarded because it is impure, as it contains some air that was present in the apparatus before the reaction started. Now, for you to obtain dry hydrogen gas, you need to pass the produced gas through anhydrous calcium chloride or concentrated sulfuric acid. In this kind of a setup, the method used to collect the gas is upward delivery method. You can see the setup I have here. The hydrochloric acid, dilute hydrochloric acid, is reacting with zinc. hydrogen is being produced, but before being collected, it is passed through a U-tube containing anhydrous calcium chloride, whose job is just to dry the gas, and then the gas is collected through the upward delivery. The reason why the method, that upward delivery method, is used is because the gas is less dense than air, so it can be able to go up in the gas jar and displace air downwards. In certain setups, this can be replaced. The U-tube can be replaced with a boiling tube or with a flask with the concentrated sulfuric acid, because, as we have said, concentrated sulfuric acid is also a drying agent for hydrogen gas. So zinc plus dilute hydrochloric acid gives you zinc chloride and hydrogen gas. That is the equation. In this preparation of hydrogen, magnesium or iron can also be used instead of zinc, and dilute sulfuric acid can also be used instead of dilute hydrochloric acid. There are 4 reactants that cannot be used to produce hydrogen. 1, nitric acid cannot be used to replace the dilute hydrochloric acid or dilute sulfuric acid. This is because nitric acid is a strong oxidizing agent, and therefore the hydrogen you produced in the process will be oxidized to water if you use nitric acid. So there will be no much production of hydrogen in such a setup. So the dilute sulfuric acid, number 2, cannot be used with calcium, barium or lead metals. This is because their solvates that will be formed in the process are insoluble. They will quickly cover the metal and stop any further production of hydrogen. So dilute sulfuric acid with calcium, barium, lead cannot be used. Number 3, the acids, dilute acids, sulfuric or hydrochloric, cannot react them with sodium or potassium. Or what I'm saying is that sodium and potassium cannot be used to replace zinc in this setup. This is because the reactions with sodium and potassium are normally very explosive. Number 4, copper cannot be used to produce hydrogen. This is because copper is lower than hydrogen in the reactivity series, and therefore it cannot displace hydrogen from the acids. Now the physical properties of hydrogen: 1, it is neutral; 2, it is colorless; 3, it is odorless; 4, it is insoluble in water; 5, it is less dense than both water and air; and 6, it is the lightest known gas. So those are the physical properties. In terms of chemical properties: 1, it does not support combustion, does not support burning. It even extinguishes any burning that is happening. It extinguishes, for example, it extinguishes a burning splint with a pop sound. And this is a confirmatory test for hydrogen. So whenever you lower the burning splint into a gas jar full of hydrogen, it will just go off with a pop sound. So hydrogen does not support combustion. Number 2, when pure dry hydrogen gas is burnt in oxygen, in presence of oxygen, a blue flame it burns with a blue flame and forms water. So hydrogen plus oxygen is water. Number 3, hydrogen is a reducing agent. It is able to reduce oxides of commonly three metals, that is copper, lead and iron. So these oxides are normally reduced to the metals. So what happens? They are deprived of their oxygen. It is taken away by hydrogen, and they are left as metals, while the oxygen that hydrogen takes combines with it to form water. So it reduces these 3 metal oxides to the respective metals, and itself it is oxidized to water. For example, when you react, when copper 2 oxide is burnt in presence of dry hydrogen gas, there is change of color for copper oxide from black to brown as it is converted or reduced to copper metal. Hydrogen is oxidized, resulting in creation of a colorless liquid, which is water. So the setup for such an experiment, as you can see, as I'm displaying here, you see that the hydrogen is coming in, dry hydrogen gas, and it is coming into a combustion tube that has black copper 2 oxide being heated. So what happens is that the copper 2 oxide will be reduced to copper. That's why it will turn to pinky brown or brown. Then there will be a colorless liquid formed inside the combustion tube, which if you carry out a test, you'll confirm that it is water. So any remainder of hydrogen will burn here at the end of the setup. So the colorless liquid formed here is water, and the brown solid is copper metal. So the other item we'll look at is how water is an oxide of hydrogen, or what we want to confirm is that on oxidizing hydrogen you get water. So we use this setup for this experiment, whereby we get hydrogen gas and put it into a tube containing anhydrous calcium chloride. As you know, this calcium chloride is used to dry the hydrogen gas. So once the hydrogen gas is dried, it is burnt in oxygen. It is ignited here in oxygen, and then what is produced is cooled using ice cold water. You realize that after cooling, the steam produced here, drops of water will be formed. That confirms that the hydrogen that we are drying and bringing here reacts with oxygen to form water, meaning that water is an oxide of hydrogen. So water is formed when hydrogen is oxidized, or it is combined with oxygen. So hydrogen is first dried up using anhydrous calcium chloride, to avoid the explosion on heating in the presence of air. You want to make sure that there is no air combined with hydrogen, and that's why you dry it up using the anhydrous calcium chloride. Then it is ignited. As you can see, it's being heated here, and in presence of oxygen, of course, and then the resulting steam is condensed on a cold surface, forming a colorless liquid. When white anhydrous copper 2 sulfate is added to the formed liquid as a test for water, it confirms by turning from white to blue. That is the confirmatory test for water. This experiment confirms that heating of hydrogen or combining it with oxygen results in formation of water. Therefore, water is an oxide of hydrogen. Uses of hydrogen: 1. Manufacture of ammonia. 2. It is used to manufacture or to make up weather forecast balloons. It is also used to manufacture hydrochloric acid, and it is used in making of rocket fuels. So in a summary, those are the highlights that you expect to be tested on in this topic of water and hydrogen. Just as an illustration, let us look at the few questions that have been brought up, just to show you so that you can go and try to answer them. And the questions that have been brought in KCSE starting 2018 and a few more years after, coming from this topic. In KCSE 2021 paper 1, there was a question on the sodium metal being placed in water in the behaviors. So there are 3 sub-questions there that I want you to go look at, and then later in another session we will be able to tackle them. And then KCSE 2018 paper 1, there was also another question on how group 1 elements react with water to form alkaline solutions. And as you know, group 1 elements are metals. So you can pick one of the metals, the way we have described how it reacts with cold water, and then use it to answer this question. The alkaline solutions, as you said, hydroxides are formed whenever a metal reacts with cold water, and hydroxides are alkaline compounds. Then KCSE 2018 paper 1 again, there was a question on the burning of candle and the production of both water and carbon 4 oxide, as we discussed earlier. So you can use that knowledge to try and address this question. In 2019 paper 1, there was a question of burning of magnesium in steam. Of course, we have gone through that process and how it happens and the observations and the reactions. Use that knowledge to try and tackle that question. Then at some point, we'll look at all questions together. Then KCSE 2020 paper 1, there was the same question on burning of candle as hydrocarbon to produce both water and carbon for oxide. So with that, we come to the end of this topic. I believe we have summarized it and made it simple, and now it is so easy for you, my students, to be able to tackle any issue that comes in KCSE or any other exam from this topic. Our aim, as I said, is to make chemistry simple for KCSE. See you in another session, and we go to another topic. Thank you very much. My name is Simple Teacher.